Assalamualaikum and hello everyone. Welcome to the video where we will discuss question for the past year for the year of 2020 and 2021. In this video, we will discuss question number 3 involving chapter 4, chemical bonding. Question 3, phosgene COCl2 is a chemical used in the production of plastics and pesticides. Given that the chlorine cannot be the central atom, A. Draw 3 possible structure of phosgene. Okay, so what is the step to answer this question? It's actually the question asks to draw 3 possible structure lah, or 3 Lewis structure. Okay, so again, how do we draw the Lewis structure? First thing first, what we need to do is to find the number of proton for C, carbon, oxygen, and chlorine, and write down the electronic configuration. You may refer to the list of constant to check the number of proton of each of the atom here. So for the carbon, we have 6, so this is the electronic configuration. Oxygen is 8, so this is the electronic configuration. And chlorine is 17. Okay, now you have already written the electronic configuration. Next step is actually you have to determine the valence electron for each of the atom. So valence electron is your outermost electron, or again your highest n. In the case of carbon, the highest n is 2. So as we can see, when n equal to 2, we have 4 electrons. So the valence electron for carbon is 4. Oxygen, again, highest n is n equal to 2. But then when we see the number of electron for the valence electron, here 2 plus 4. So for the case of oxygen, there are 6 valence electron. Last but not least, for chlorine, okay, the highest n is n equal to 3. And then we can see there's 2 electron plus 5. When n is equal to 3, so chlorine has 7 valence electron. Okay, once you have written down the valence electron, next step to draw the Lewis structure is to calculate the total valence electron. So carbon, we have 1, so 4 electron. Oxygen, we also got 1, so we have 6 electron. But chlorine, we have 2, so it will be 14 electron. So the total number of electron, we will have 24 electron. Once we have calculated the total valence electron, then we have to draw the Lewis structure. We have to determine which one is the center. Based on the information here, it mentioned that chlorine cannot be the center. Okay, so for a given molecule, okay, usually we will take the least number of atom lah to be our center. Okay, that's why chlorine cannot be the center lah, because we have 2. Okay, but then there are 2 choices, chlorine or oxygen. So how to determine the center? Then you have to compare the electronegativity. Okay, so please write in your notes, SK015. What does it mean by SK015? Carbon, nitrogen, oxygen, fluorine. So this one will be higher electronegativity. Electronegativity means ability to attract electron lah. Okay, to attract electron. So group 17, we have 7 valence electron. So it needs 1 more electron to octet. So that's why group 17, we consider it as high electronegative atom lah. But for the case of period to elements, SK0, fluorine will be the most electronegative. Okay, for the center, okay, for the central, it must be the least electronegative. So between carbon and oxygen, which one is the least electronegative? Is your carbon. So your carbon must be in your center. Okay, so we know that our oxygen and chlorine is the terminal atom. Okay, so next step is we're going to connect the terminal with the center. Okay, and then we're going to minus. Remember that for each one bond, we have 2 electron here lah. So here we have 2, 4, 6 electrons. So we're going to minus 6. So what happened to the 18 electron? Okay, the remaining electron, we're going to put it at the terminal atom so that all the terminal atom can achieve octet. So right now, let me check. So for the chlorine already got 2. But then it needs 8 to achieve octet. So it means that it needs 6 more to achieve octet. Not only for the chlorine here, oxygen here also only got 2 electron. So it needs 6 more. The same goes for chlorine here. The chlorine here only got 2. It needs 6 more electron. So the total electron used is 18. So now, okay, we have no electron left. Okay, next is we have to check whether all the atom already achieve octet or not. So here what we have, chlorine 8, oxygen 8, this chlorine pun 8. How about our center? Our center, carbon only got 6. Here, 1, 2, 3, 4, 5, 6. Okay, so 6 is considered as incomplete octet. But then again, for incomplete octet, it is only for berbal, beryllium, boron, aluminium. Carbon is not berbal, so it must achieve octet. Okay, so how does the carbon achieve octet? So again, here actually, from the question itself, it gives in draw 3 possible structure. So there are 3 possibility. So first possibility is that again, chlorine only got 6. So it needs 2 more electron. So it's either from the chlorine left, from the oxygen, or the chlorine on the right. So we need to show the 3 possible lah from each of the different atom here. So first I'm going to show if the chlorine on the left will share one of the electron with the carbon. First possibility is the chlorine on the left share the electron. Remember, there's no more lone pair here. What it will become, we have our double bond here. So when we check each of the atom, chlorine here got 8. The carbon here also got 8. So this is the first possibility. So this is considered the Lewis structure. This is not the Lewis structure because again, not all the atom achieve octet. So this one is one of the 3 possible. So I'm just going to label this one as structure 1. So this is the first possibility. So there's 2 more possible structure lah. So what I'm going to draw this one again. For structure 1, we have share from this chlorine. So structure 2, it's up to you whether you want to share the electron from this oxygen or from this chlorine. Both are fine. But then I'm just going to start with this oxygen lah. Okay, so right now this oxygen will share the electron. Okay, so again, when the oxygen share the electron here or the lone pair, so when you draw the new structure, there's no lone pair left lah. So we just have our double bond. So when we check, this carbon got 2, 4, 6, 8. This oxygen, even though it shared, it also got 2, 4, 6, 8. So this is the second possibility, which I'm going to label as structure 2. Now we have 2 possible structure. Again, the question wants 3 possible structure. So how about the last one? Okay, for the last structure, since we have shared from this chlorine, from this oxygen, right now we're going to share from the right side of our chlorine. So again, because our carbon only got 6 electrons, so it needs 2 more electrons lah. So this chlorine will share 1 lone pair here or 2 the electrons. Since the chlorine here share the lone pair here, so there's no more the lone pair on the chlorine. So what happened here? We have our double bond here. So this is my structure 3. So now we got all the 3 possible structure of phosgene. Okay, remember the possible structure or our Lewis structure, make sure that each of the atom already achieve octet lah. Okay, so if you answer only by this one is not the Lewis structure yet because carbon only got 6. So for the structure, 3 possible is this one, where all the atom already achieve octet. Make sure you label the structure as well. Question B, determine the most plausible structure and give your reason. Okay, so if the question asks to determine the most plausible structure, plausible too is the same as the possible one lah. Because we have 3 possible structure, we have to choose which one is the most accurate one. Okay, so how to choose which structure is the most plausible? You have to calculate the formal charge. Okay, so what is formal charge? This one you have to memorize lah, how to calculate it. So this is the calculation. To determine the formal charge, we have to calculate the number of valence electron minus the number of bond minus the number of non-bonding electron. Non-bonding electron and lone pair are not the same thing. Okay, so for example, chlorine here. So for example, I draw it this way kan, HCl. Okay, for Cl, we consider this as 3 lone pair, right? Because we have 1, 2, 3. But non-bonding electron is that we have to calculate how many non-bonding lah. This case, non-bonding dia 1, 2, 3, 4, 5, 6. Non-bonding electron, we have to calculate the electron itself. How many? Okay. But then, how to answer the question? So let's refer back to what we have answer in question A. So this is the tree structure that we have draw from the part A. So now what we're going to do is actually we have to calculate formal charge of each of the atom for each of the chlorine, oxygen, carbon, and for each of the structure we have 2 chlorine kan. Since we have 2 chlorine, I'm just going to label it here. Each of the structure we have chlorine A, B, A, B, A, B. Okay, so now let's calculate the formal charge. Again, I'm going to start with structure 1, and I'm going to start with chlorine A. So chlorine A, again, how to calculate formal charge? Valence electron, we got 7, minus the number of bond. For the chlorine, we have, so when you check chlorine A, we have only 2 bonds, so minus 2, minus non-bonding electron. So is there any non-bonding electron? Here we got 1, 2, 3, 4. So minus 4. Hence we will get positive 1. Okay, next we're going to calculate for carbon. Carbon have 4 valence electron minus the number of bond. Again, carbon here have 1, 2, 3, 4. So minus 4 bond minus non-bonding electron. Is there any non-bonding electron here? There's none. So here minus 0 equal to 0. Okay, next you can continue with chlorine B, or you're going to continue with O. I'm just going to start with O lah, oxygen. There are 6 valence electron minus the number of bond. Number of bond, oxygen here. Again, check oxygen. Only got 1. So, minus 1. Okay, minus how many non-bonding? Non-bonding electron. Here we got 2, 4, 6. Okay, non-bonding electron. We have to calculate the electron. Minus 6. Hence, we will get negative 1. Last but not least is for chlorine B. Again, chlorine B got 7 valence. But then how many bond for chlorine B? Chlorine B only got 1. Minus 1. How many non-bonding electron? Non-bonding 1, 2, 3, 4, 5, 6. So minus 6. Hence we will get 0. Okay, so that's why it is important for you just to label the chlorine A and B lah. Maybe sometimes it could be the same formal charge, but it could be different as well. So just to be safe, just label both and calculate both lah. As we can see here, it has 2 different formal charge. So I have shown for the step for the structure 1, then you can try yourself for structure 2, structure 3, whether you get the same answer as mine that I will show later. So if you have done the calculation, then you will get these all the values lah. Please check whether you get the same as mine. Okay, so this is all the formal charge of each of the atom itself. Okay, so now once we have calculated, then we have to determine lah the most plausible Lewis structure. So how to determine the most plausible Lewis structure? So there are 3 reasons. So once you determine, you have to write in sentences lah. Okay, so what is the 3 reasons? So for the most plausible structure, the first one is the lowest formal charge. Okay, so the total formal charge, if you calculate, all will be the same. But then we want all the individual atom to have the lowest formal charge possible lah. If possible, we want all the atom to got 0. Okay, if not, then the negative formal charge must be on the more electronegative, or the positive formal charge on the least electronegative atom. So when we check here, actually, if we total up this value, we get 0, 0, 0. But then again, remember the lowest formal charge is not the sum of the formal charge. This one we have to check for each of the atom itself lah. Okay, so for the case of structure 1, we got 0. But then here we got 1 and 1, positive 1, negative 1. So structure 2, here we got all of it to be 0. So the structure 2, that is the most plausible. Because again, lowest formal charge means that the lowest for each of individual atom. Okay, so for example, if you have labeled your structure a bit different, this may be structure 3 for your structure. So make sure the most plausible is this one. The double bond must be bonded towards the oxygen. Okay, so how to write it down? So we have to mention Structure 2 is the most plausible, or is either you want to write down most plausible pun accepted. Okay, then I have mentioned the reason lah, because it has the lowest formal charge. Okay, so again, if the question asks the most plausible, okay, to determine it, first you have to calculate the formal charge lah. And then once you calculate the formal charge, how to determine the most possible? There are 3 reasons here. So that is the solution for question B. For question C, determine the hybrid orbital for the central atom of the most plausible Lewis structure. Okay, so from the previous question, we already got our most plausible structure, which is this one. Now we have to determine the hybrid orbital. What is hybrid orbital? Hybrid orbital, we have learned about sp, sp2, sp3, sp3d, sp3d2. Okay, so why after sp3 must start with d? Because p orbital maximum we already got 3. So that's why we're going to start with d lah next. Okay, so how to determine the hybridization? So here is actually based on the total electron pair. So this is the total electron pair. So what does it mean? This is when we add up our bonding pair plus lone pair. Okay, so once you got your bonding pair plus lone pair, you will get the total. The total, then you will get the hybridization lah. Again, why sp is 2? Because you got 1s plus 1p, so total 2. sp2, 1s plus 2 of p orbital, so total 3. Okay, so now we have to check again for the central atom. So for the carbon, so we know that for the carbon have how many bonding pair, how many lone pair. Okay, so again, how do we know it? We have to write down yang class lah. Class which is A, B, X, E, Y. B stands for bonding pair. E stands for our lone pair. Okay, so for our carbon, okay, so as we can see, it has 4 bond. Okay, but bonding pair means how many it bonded to. How many atom it's bonded to. So carbon bonded to chlorine on the right, chlorine on the left, and oxygen at the top here. So the class for carbon is AB3. Okay, so does it have again? Class is ABXEY. E stands for lone pair. Does it have any lone pair on the carbon? No, it does not have. So the class is AB3 lah. Okay, then we have to mention AB3 stands for that the carbon has 3 bonding pair. So if we have 3, again, 3, check here. Hence, we know that our carbon is sp2 hybridized. So again, this carbon has 3 bonding pair. So here I just have an extra question. So this one, I just want to determine what's the class and what is the hybridization lah. Okay, so for this carbon, okay, so even though it does not follow the shape, okay, this carbon has 1, 2, 3, 4. It has 4 bonding pair. Again, bonding pair, how many atom bonded lah? At the top, at the bottom, on the right, on the left. So here, if I written down this one, it will have 4 bonding pair, 0 lone pair. So the total is 4. Is it 4? It will be sp3. Okay. How about CO2? Okay, CO2, again, ABXEY. Okay, bonding pair. It is bonded to oxygen on the right, oxygen on the left. So it is AB2 lah. Means that it has 2 bonding pair. Does it have any lone pair here? So no. So if 2, then we got our sp. Again, bonding pair does not refer to the number of bond, bukan. How many pair dia ada lah. Berapa kawan dia ada. So for example, ClF3. Okay, ClF3 ni ABXEY. Case ni berapa bonding pair? Bonding pair dia ada 3. 1, 2, 3. We have 3 fluorine. So here we have 3 bonding pair. Okay, does it have lone pair? Okay, it does. 1 here, 2 here. So we have 2 lone pair. So 3 bonding pair, 2 lone pair. When we total up, it is 5. 5, it means that this is sp3d. Okay. So this is an extra example So if you be unsure, you can rewatch it again, or you can add in your notes lah. Now back to the question again. So we have determined the hybrid orbital, okay, for the most plausible structure. But then again, when you see the marks here, you got 4 marks. So it seems impossible lah kan. This is the only solution for 4 marks worth of question. So next step is actually what you have to do. You have to show the hybridization lah. So how to show the hybridization? You have to show the ground state, the excited state, and hybridized state. Okay, so how to determine the ground state, excited state, and hybridized state? So first, what I like to do, from the structure that we have drawn, we know the most possible. So first step is actually, you have to label your bond, okay? So for example, remember for each single bond, it means that here we have a sigma bond, sigma bond, sigma bond. But then for the case of carbon oxygen, we have 2 bonds. So if the first one is sigma bond, the third one or the second one, sorry, will be your pi bond. The same case here lah. If you have oxygen double bond, first is sigma, second one is pi. Okay. If you have nitrogen triple bond, here is sigma, here is pi, here is pi as well. Okay. For the case of carbon chlorine, so this is the first bond lah between carbon and chlorine. So that's why it's sigma. The same goes for the chlorine on the left hand side. Okay, next what I like to do is I'm going to label all lah. Once you have labeled all the bond exists in the structure, okay, so what I like to do next is I have to label. I like to label this one lah. So please add in your notes or in your exercise. So if we have sigma bond, it means that we want unpaired electron. This case is for the hybridized version. Okay, the same goes for lone pair. Lone pair is hybridized orbital. But this case, kalau lone pair, it must be paired electron lah. Okay, for pi bond, we want unpaired electron. In this case, unhybridized. So specifically, for the COCl2, so what we have is that we have 3 sigma bond. So what does it mean? So we have 3 unpaired electron, which is hybridized. Okay, so that is for the sigma bond. But then again, for the carbon, we have 1 pi bond. So I'm just going to write down. So for my ground state, excited state, hybridized state. Okay, for my hybridized state, okay, so I will have 3 unpaired electron, which is hybridized, and 1 unpaired electron for the unhybridized. Okay, don't forget to include the carbon is sp2 hybridized. Okay, so then we will start our hybridization with the ground state. Okay, so ground state of carbon, we know that it is 2s2, 2p2. Again, carbon is 6, 1s2, 2s2, 2p2. But then again, for the hybridization, we only show the valence one lah. So here is the ground state. Okay, so next is for the excited state. Okay, so for the excited state, again, based on what we have labeled here, what we want is actually, we want 4 unpaired electron total. Okay, because 3 unpaired hybridized, 1 unpaired as well, but it is unhybridized. But still, we need 4 unpaired electron. So what happens is that one of the electron here will be excited to this 2p orbital. Last but not least, then we have to show lah the hybridized state. Again, for the hybridized state, remember it is sp2 hybridized. sp2 hybridized means that we only have 3 lah. Again, 3 unpaired electron hybridized. So not all that we gonna write down as the hybrid. We only want 3 as the hybridized, which is sp2. But then we have one more electron which we have not written, the unpaired electron. However, again, based on what we have written here, there is one electron, unpaired electron, which will be unhybridized. So it does not include in the sp2 lah. So then you have to draw the electron as well as label there is 2p unhybridized. Okay, so since the question asked to determine the hybrid orbital with the 4 marks, so that's why you're not gonna start. You're not gonna stop until here lah. You have to finish up with the hybridization step, the ground state, the excited state, the hybridized state. But then again, not all the electron will be hybridized. So that's why first step, the hybridization, you have to know the total electron pair to know the hybridization, and then you have to write down this one where What does it mean by sigma bond? What does it mean by the pi bond? Okay, because remember, even though we have 4 unpaired electron, but not all of it will be hybridized. Question D, name the molecular shape and draw the overlapping orbitals of COCl2. From the previous question, we have determined that the class for our central atom is AB3, which means that it has 3 bonding pair. Since it has no lone pair, so we do not write down the E lah. Okay, so for the molecular shape, so first, what you need to write down the EPG, which is the electron pair geometry. Okay, so if we have 3, so it means that it must be trigonal planar. Since the central atom has no lone pair, so it means that the electron pair geometry will be the same as the molecular geometry. So for all of this shape, you have to memorize lah, especially the electron pair geometry where the basic molecular geometry or the basic molecular shape where we have no lone pair are present in the central atom. This is a website for a simulation. Okay, I have included the simulation in the description link as well. Okay, so all of this shape is something that you have to memorize lah. So when you open the link, you're going to see this one. So you're going to choose the model. Okay, so here we have 2 bonding pair. So when you look based on your bottom corner left, we can see that we have the name, which is for the electron geometry as well as the molecular geometry. Okay, so our syllabus is 2 linear, 3 trigonal planar, 4 tetrahedral, 5 trigonal bipyramidal, 6 is octahedral. So all of this shape is something that you have to memorize lah. Okay, so for our COCl2 just now is actually we have 2 single bond, and then we have 1 double bond for our oxygen. Okay, so as you can see, the electron pair geometry is trigonal planar. The molecular geometry pun is the same one. Okay, so again, it is based on the bonding pair lah. The second part of the question is to draw the overlapping orbitals of COCl2. Okay, so first, to draw the overlapping orbitals, you have to show the hybridized state or the ground state of the atom. Previously, we have determined the hybridization for carbon as well as we have shown the hybridization step for the carbon itself. Carbon is sp2 hybridized, okay, and then we will have 3 unpaired electron on the sp2 hybridized, 1 unpaired electron for the 2p unhybridized. Okay, again, why? Because for the case of COCl2, carbon have 1, 2, 3 sigma bond, okay, and then it has 1 pi bond. For each sigma bond, it means that we have unpaired electron which will be hybridized. Carbon 1, 2, 3, this one. Okay, and then carbon has pi bond as well, unpaired electron for the unhybridized. So that is for the carbon. Okay, next for the chlorine. So for our terminal atom, we don't have to hybridize. We only show the ground state of chlorine. Since the valence electron of chlorine is 3s2, 3p5, then this is the drawing lah. Again, we have only, for chlorine, we only have 1 unpaired electron. Again, why? Because the unpaired electron ni yang akan pair with the carbon here lah. The carbon that is hybridized. Okay, so that is for chlorine. Okay, how about the oxygen? Okay, so for the terminal atom, there's an exception. The exception is that for the terminal atom, if we have nitrogen and oxygen, which is double or triple bond, it will be hybridized. In this case, our oxygen is double bond, so we have to show the hybridization lah, or the oxygen is hybridized as well. Okay, again, so how do we determine the hybridization for oxygen? In the case of oxygen, we can see that it has 1 sigma bond, 1 pi bond, as well as it has 2 lone pair. So the same case as carbon previously. So it means that if we have 1 sigma, means that we have 1 unpaired electron for the case of hybridized. If we have 1 pi bond, so again 1 unpaired electron, but it is unhybridized. Okay, but for the case of oxygen, there's extra. There we have 2 lone pair. So how about the 2 lone pair? It means that we have 2 paired electron. In this case, paired because ada pasangan. And then it will be hybridized. Okay, so we're talking about hybridized. Again, oxygen here. Okay, oxygen for the class here we have It is bonded to only one atom, AB1, only bonded to one carbon, but then it is bonded to 2 lone pair. So total we have 3. So 3 we have sp2 hybridized. So again the hybridization, since we have 3, 2 lone pair and 1 bonding pair, only bonded to one atom. So 3 is sp2. Okay, so then next we have to do the ground state, excited state, hybridized state. So for the ground state of oxygen, so since it has 8 proton or 8 electron, 1s2, 2s2, 2p, 4. Okay, so this is the ground state. Okay, so for the excited state, so again, what we want is actually 2 of unpaired here and 2 paired electron. So there's no need for the excitation. There's no need for it to be single sebab tak ada pun empty orbital. So for the excited state, it will be the same. The last step, we have to show the hybridized state. Again, we know that it is sp2 hybridized, and for the case of hybridized, we know that it must have 2 paired electron and 1 unpaired electron. Again, sp2 means it has 3. So this 1, 2, 3 will be our sp2. And then don't forget, we have one more electron on the p orbital, which is the unhybridized. Okay, so why is it unhybridized? Because this is needed for our pi bond. Okay, so we have drawn the hybridized state not only for carbon, okay, as well as for the oxygen, because that's the exception lah. Okay, for the chlorine is for the ground state. Okay, once we have determined this one, then the next step is to draw the orbital overlap. So how do we start? We start with our carbon. Carbon is sp2 and the shape is trigonal planar. So trigonal planar, so the shape will be 1, 2, 3. So this is for our carbon sp2, and then remember, for each of the sp2 orbital we have 1 electron. So that is for our carbon. Okay, so next is easier for us, is actually chlorine lah. Chlorine, again the unpaired electron is 3p. So 3p, the shape is our dumbbell. Make sure label this is 3p, and then you have to show lah the electron is pairing up. Okay, don't forget, this is our sigma bond. So label our sigma bond. Okay, so how do I know sigma? This one. Okay, so carbon chlorine done. Okay, but then we have our oxygen. Okay, oxygen is also, we have A, B, E2. So 3. So total it's 3. Okay, so if 3 is the same one as trigonal planar, so the shape will be trigonal planar like this lah. So oxygen is sp2, again 1 unpaired is actually used for our sigma bond. Okay, so here I have to label my sigma bond. Okay, once I have labeled my sigma bond, remember the 2 orbital is paired electron, paired, so here. Still the same one, is still sp2, sp2, but then here is my lone pair lah. Okay, so then I have 1, 2, 3. I have 3 of my sigma. Okay, last but not least is my pi bond. So how to draw the pi bond? Okay, pi bond is this one, 2p unhybridized. Okay, so make sure it's parallel, so it will be easier for us to do the parallel this way. So this is my pi bond. Again, this is my 2p unhybridized. 2p means it's a dumbbell. Then it must be parallel. Okay, so for the case of pi bond, it is overlapping side to side. So, but then when you draw it in terms of 2D, we can't show it side to side. We just draw the bridge. Okay, and then label one of the bridge with the pi bond. Okay. So the question is quite long because it's actually step by step kan. Okay, so that is all the solution for the past year question for the year of 2020-21 for question chapter 4.